hard to believe, really, that just 3 years ago, a handful of us moved from a tiny, cramped office full of computers just up the road into a completely empty industrial unit that would become DC1. In here, in just a matter of months, we built our entire facility, we built our team, we built our precision temperature-controlled machine shop, our avionics development center, our metrology lab, our power electronics lab, our design suite, our development suite, and all of the other facilities that we've needed to develop HX50 and GT50. With those facilities, we developed the capability to make aerospace quality gears, aerospace quality bearings, all of the components necessary for GT50 and all of the power electronics and software capabilities. But very quickly, we ran out of space again. Within just a year, we'd opened DC2 and DC3 that enabled us to make composite molds, composite patterns, infuse full airframes, all of our laminating capabilities, and eventually produced 2 HX50 airframes, fully fitted and ready for public display. But again, we're now running out of space. The team's growing, the facilities are growing, and it's time to step it up again. Welcome to PC1, our brand new 76,000 square foot production facility right here in the heart of Stafford. We now have the entire Hill team based here under one roof, all of our design staff, our development staff, our production staff, and our admin support staff as well, all here working under one culture with one key goal of getting the development finished and the aircraft into production. Within this facility, we will complete all of the development, all of the approvals, and then commence early series production of HX50. And beyond that, the facility will become one of the elements of our modular approach to production. These facilities don't build themselves. We've started again here with an empty box, albeit a bigger box, but we've now got to go ahead and build yet another helicopter factory. So over the course of the last few months, we've been essentially completing the design and development of our production facility for the early prototype aircraft and then the early series production aircraft, laying out the factory floor, laying out all of the other facilities that we need in here for design, development, approvals, all of the business administrative functions, customer care and support. All of that has now been designed and we're in the process now of implementing it. So if we take a look at the shop floor first, then from an empty box, we've had to add all of the electrical power infrastructure needed to locate this big, heavy-duty industrial equipment that we need. Large, heavy-duty cables running the full length of the factory, similarly with compressed air lines, with water lines, and all the other services that we need to support the wide array of manufacturing equipment that we need within the factory. In addition to that, we've had to lay down specialist foundations to support the heavy production equipment that we've installed here at PC1. The large gantry mill, this is a 15 by 15 meter machine, that has a specialist foundation and specialist ground attachments, as well as all of our precision CNC machines that you've seen before at DC1. All of those machines have had specialist foundations implemented here. We'll shortly be completing our mezzanine floor to create an environmentally enclosed chamber around them to hold those temperature controls that we've shown that we need to hit the tolerances for gears and bearings and other precision components. Let's go and take a look inside and I'll show you what we've been building. So composites manufacturing is at the very heart of our business. And to be able to make cost-effective composites, you really have to control every element from end to end. You have to be able to produce patterns and molds, then you have to be able to do all your own laminating, your own curing, your own trimming, even down to your own paint and finishing. Now, a crucial part of this during development is your ability to make patterns and molds really quickly. So we need to iterate the design quite often, and if you don't have the capability to produce these things in-house, then your timescales and your costs go out the window. During our time at DC1, 2 and 3, we developed the whole suite of technologies that we needed to be able to produce cost-effective, inexpensive patterns and molds for both prototype purposes and then also all the way through to full production grade tooling solutions. The problem that you have when you're vertically integrated, however, is that you are totally dependent on the reliability of your plant and equipment. If your machine fails, it stops production. And as you may be aware, we set up our composites facility during COVID, and so the only way we could access a gantry mill quick enough was to buy a second-hand one. And that machine has been the bane of our life right from the word go. So now we're starting afresh, and we've bought a brand new top-of-the-range gantry mill to allow us to make our patterns and molds faster, more accurately, and more importantly, more reliably than ever before. This is our all-new composites gantry mill. Arrived from Italy in 5 articulated lorry loads. It's taken a team of engineers 6 weeks to painstakingly build it. It sits on a trench that we excavated 1 metre deep to build a machine foundation strong enough and stiff enough to support the bed and the pillars to maintain the accuracy and the tolerances needed to produce accurate composites patterns and molds. It requires a complex web of electrical, pneumatic and control services fed to it from around the factory to control its many systems. It lives, or it creates, its own environment to contain all of the powder and dust that it makes as it manufactures high quality patterns and molds from powder-based, polystyrene-based and model board-based materials. And then it has its own dust extraction system that palletizes that waste and keeps it all out of the factory, avoiding contaminating the clean areas of the rest of the production facility. Why would we go to such extreme lengths for a machine like this? It's quite simple. If you want to control the cost of your composite components, you have to control that process from end to end. You have to be able to make patterns, molds, and parts all the way through to finished painted goods if you want to truly control the costs. And to do that, if you're going to make big composite parts, you've got to make big composite molds. If you want to make big composite molds, you're going to need to make big composite patterns. And big composite patterns require a massive gantry mill. This machine is able to produce patterns that essentially are 4 meters wide, 8 meters long, and up to 2 meters high. So anything that we could possibly dream of doing for HX50 and a good deal of our future products. Beyond that, in production, the machine is also able to keep up with over 500 machines a year in terms of the finished composite part trimming, all of the glazing trimming, and a variety of other operations to make sure that our finished composite structures are the most accurate that they can possibly be. In addition to that, this machine represents a huge step up for us in a whole host of other areas. Fundamentally, this state-of-art 5-axis machine is able to hold just 10 microns in positional accuracy over the space of about 1 meter. This means that the accuracy with which we can make our patterns and molds is far, far higher than it has ever been before, but more importantly, the quality of the flowing A surfaces that we make will be absolutely perfect, needing the absolute minimum of hand finishing to give you that silky feel to the external contours of HX50. But it's not just about the quality, it's more than that. In addition to the surface quality that this machine allows us to generate, the reliability will be second to none. So if you remember in the early stages of building the first generation of patterns and moulds for HX50, our single biggest challenge was that the second-hand gantry mill that we'd bought during COVID was simply so unreliable that we had to nurse it through every manufacturing operation. All of that stops here. This is a completely self-contained, modern, reliable machine. It's capable of running 24 hours a day. As you can see, it has a modern, high-speed spindle. We have remote monitoring of the machine, as well as computer controls from external stations, and we have a modern 16-tool tool changer. What that means is whereas previously we'd have had to stop programs to change tools, with this machine, we can now do everything from roughing through to the sculpting of the surfaces, through to picking out intricate details and fillet radiuses, all within a single program, all within an operation, all lights out overnight. So what that means for us is both in terms of patterns and moulds, we can take simple, low-cost tooling materials, such as the materials waiting to be processed over here, our conventional polyboard for the big patterns that we make, and higher grade model boards and foams, low-cost composite materials in through the front door, high quality, precision aerospace patterns and moulds made in-house, right here, production ready at PC1. To give you an idea of the material flow around the factory, when the finished patterns and moulds come off the gantry mill, they've been through the trim shop to be prepared. They then go over to this vast space in the middle of the factory, which is to be our laminating shop. This gives us a clean room environment in which we eliminate all of the dust to make sure we produce high quality laminated components. From that, the components move over to the other side of the building into the oven that we've brought over from DC2, and then when they're finished curing, back into the trim shop and then over to paint to receive their finish. One of the things that we've had to do a little bit differently here at PC1 is the way we create the temperature controlled environment for the precision machine shop. In DC1 that was easy, it was a small building so we just temperature controlled the whole lot. Here it's impractical to attempt to temperature control a building this sort of size. So what we've had to do to create that enclosed environment to temperature control all of the key machines is to build a mezzanine floor. And to put it in perspective, this mezzanine floor is twice the size of DC1 was in total. It's huge, and on top of the mezzanine floor we're going to be adding our avionics shop, our wiring shop, our upholstery and trim shop, and all of the facilities that we need to make the crash-worthy and acrylic glazing components for HX50. Beneath the mezzanine floor, we add all of the lighting and all of the air conditioning and refrigeration systems we need to maintain the temperature controls to the level required to make precision gears and bearings. Our suite of state-of-the-art CNC machines are now happily installed in our new precision machine shop here at PC1. All the services are connected and the machines are back online. It'll take a little while before we're able to produce precision components once more, as we need to wait for the rest of the mezzanine floor to be completed and the whole environment to be sealed and temperature controlled. But as soon as that's done, over the course of the next couple of weeks, we'll be back to producing gears, bearings and other precision aerospace components to the tightest possible tolerances. Irrespective of how good the helicopter is, if the finished paint job isn't up to scratch, you're going to get the keys thrown back at you. This is our very first paint booth installed here at PC1 over the last couple of weeks, and the purpose of this is to develop all of the elements of the surface preparation and paint application and finishing processes necessary to deliver world-class finishes on all of our production aircraft. Now, that might sound like a simple thing, but the reality is painting composites is significantly more complicated and troublesome than painting metal structures. And the reason for that is the fibrous nature of the internals of the structure and the resin. All of those things combine to make panels that are much more difficult to create a perfect glass-like paint finish. Over the course of the next few months, while the structural team are finalizing the structural testing of the flight prototypes, we'll be developing all of the necessary paint processes, trading those off against weight and performance to make sure that every single HX50 has a world-class paint job. With the manufacturing infrastructure reinstalled here at PC1, the IT systems moved over and upgraded, the offices ready for habitation, it was time for all the guys at DC1 to pack their computers into their cars and come and join us over here. Now, so many of us here had been completely preoccupied with just getting stuff built and getting stuff working and being ready to have everyone moved on the 15th of June, that you don't often stop and think about just how big a step this is for us. And when some of the staff came over for the first time, for them, it was the first time they'd seen any of this. And some of the reactions really go a long way to show just how much this matters to all of us. Tim is one of our hardest to impress members of the team, and he took one look at the place and said, "Jace, it feels like we're on the home straight now." Craig came in and just beamed from one side of the face to the other, saying that, "Oh, this is just massive." And then Stuart, our Chief Performance and Loads Engineer, was walking around the whole site with his backpack on, looking like a tourist. It was really, really lovely. And at last, we've now got everybody all under one roof for the final push. Now, in other good news, my helicopters are home. So after a very protracted stay in the US following Heli Expo, waiting to clear customs, and then a long boat ride home, and then getting stuck in customs on the UK side as well, our helicopters are finally home. And that's good news on a number of fronts. It means that the machines will be available just in time for the new customer reception area here at PC1 to be online for tours to start again for customers and prospects at the start of September. So you'll be able to come to PC1, visit the facilities, see the development team, the development activities, all of the production facilities, and see the helicopters for yourself in the flesh. Let's talk about our Generation 2 HX50 fuselage. Over the course of the last 2 years, you've watched us develop an end-to-end composites design and manufacturing capability that's enabled us to design, build low-cost, high-quality aerodynamic composite structures to deliver HX50 as you see it here. However, during that period, while a lot of our time and energy has been focused on how we build molds, how we build patterns, how we trim the composites, how we assemble all of these things and control the quality, the design team have continued to evolve the design of the aircraft itself. Remember that the airframe is in fact the stickle brick that everything else attaches to. So as our drivetrain and our engine and our flight controls and our undercarriage and our wiring system and our avionics all continue to evolve and develop, thus the airframe has to evolve to adapt and accept all of those interfaces back to the aircraft. And indeed it has. So the Generation 2 aircraft, the Generation 2 structure, really embodies all of these changes. We capture all of the things that have continued to evolve while we've been developing the manufacturing processes, but furthermore, the act of building the first aircraft has really consolidated and improved our knowledge of how best to build these aircraft in the volumes that we now have to. So in addition to capturing the design changes, there are a number of learnings from having developed the composite manufacturing capability that now enable us to design a manufacturing process and methodology for HX50 far better than that we envisaged at the start of the process. Let's start by talking through that. You may well remember from the early videos that HX50 has what we call a monolage, a monolithic cabin that provides great strength, great stiffness and elegant aerodynamic performance with a single piece fuselage. The challenge, however, with that is clearly it has to be externally tooled. And what that means is once you've got but the first few plies in there, the molds have to be assembled and the foam cores and all of the internal structural details have to be laminated inside the cabin. And you will have seen from some of our production videos that that usually involves 2 or 3 or even more laminators trying to work inside the tooling to get the B surfaces down, the foams in, and this results in a real bottleneck in our ability to produce these aircraft at the rate that we now want to. We've subsequently developed a greatly improved method for tooling the airframe. So we've still maintained the idea of a monolithic external shell, but we've actually now developed a new way of tooling the aircraft that means we can break down the vast tools that used to be required to make the key surfaces of the aircraft into much smaller pieces. This is much akin to what's done in automotive composites, where you want a large number of people doing small amounts of work that allows you to much more readily scale the process for production. So we've developed a new tooling strategy. This allows us to do much more work on open tools. We then bring those tools together, add splice joints to create the fiber integrity, and the whole airframe can be built in a much more manufacturing orientated fashion. So huge development on that front. We'll be telling you much more about that over the course of the coming months as we go through tooling production and then build of the first structural demonstrators for HX50. In addition to that, a lot of the core design details have also been captured in this new version of tooling. So earlier, late last year, you saw us develop an improved brow line to improve the upward visibility that the cabin affords for our tallest customers. In addition to that, we've also improved the space in the bottom corner of the airframe down here to accommodate the latest generation of the Hill crash-worthy crew seat. Beyond that, we've got all new doors with improved structures, improved stiffness. We're improving the way that we mount the hinges. We've also got an improved multi-point locking mechanism in development as well. All of this gets captured in the next round of tooling. We're making some further enhancements to the door recesses to make them easier to laminate, to improve the bond flanges that are currently vulnerable to damage, and to make the whole system much more robust in service than the first version of the airframe. We've also substantially simplified the way that the undercarriage attaches to the airframe, both at the front and the rear, for both the wheeled and the skidded version of the aircraft. The latest version of the tooling also embodies the latest version of the Hill landing light system, both the wingtip lights and the nose lights, and it also embodies the signature lights down the side and the updated chrome strip as well. In addition to that, we've also included the hard points on the belly for all of the utility equipment that HC will require to be attached to it. We're implementing the hook attachment detail in the main crossmember at the back of the airframe. We've got an all-new scheme for the gearbox mounting to improve the vibration absorption and the reduction of transmission of rotor vibration back down to the airframe. And then in addition to that, we've also got a greatly improved trim tank assembly that fits exterior to the fuselage in the nose area, not to mention the very latest version of the HX50 flight control system. So from across the board, all of the latest enhancements that have been developed over the course of the last couple of years are now being captured in this next version of tooling, which will be used for structural test, ground running, flight test, and eventual production. The whole point of the HX50 program is that we're making a next generation general aviation aircraft that truly enables robust VFR flying both at day and at night time. And for a helicopter pilot, that very much means that you need a robust landing light system. One of the areas that we've been working on extensively over the course of the last few months is the HX50 landing light system. And the purpose of that is we need to make sure that night VFR operations are safe, or as safe as they can be, wherever you are in the world, be that on airport or off airport. What I've got in front of me here at the moment is a range of the various enhancements that we've made to the landing light systems over the course of the last few months. And I'm going to talk briefly about some of the testing and development that we've been doing on ground-based test rigs. So if we take the nose light cluster to start with, the way the landing light system works on HX50 is the nose cluster provides you a very focused landing light beam. And this is the high power, high intensity, narrow focus beam that punches through the atmospheric moisture and the atmospheric particulates and illuminates the landing area at a typical descent angle. The wingtip lights that you can see behind me provide a lower intensity light, but a much broader spread focus. And the purpose of that is that it doesn't contribute very much when you're high and descending down to your landing, but once you get into your landing area, you get a much better peripheral illumination than it's been possible to do in previous generations of aircraft. What we're doing here is developing the optimum optics and LED combinations to, while being sensible about the amount of power we use, give the best possible illumination and situational awareness for anybody using the system. While our first generation light provided comparable performance with existing aircraft landing lights, we were keen that with the advances in modern optics and the advances in modern LED technology, we really wanted to enhance the performance of the landing light to allow you to start to determine surface textures and potential obstructions much higher than was previously possible. This second generation of nose cluster used much more focused optics and much more powerful LEDs to deliver that. And with this, we generated about a twofold increase in the range that these lights can punch through the atmosphere. This really delivered the level of performance that we wanted, but we were very cognizant that there was still a significant amount of headroom left in what modern LED technology and modern optics could do before we started to get to the levels of power consumption that have been typical for landing light systems. So with that in mind, we developed two additional clusters. These two are essentially identical, but with the exception that the outer LED clusters in this point slightly outwards, so that we still get a very focused central beam of illumination, but a slightly broader band of high intensity light as you get a bit closer to the ground. So these two units are awaiting testing at the moment, but these units themselves offer about a 2 to 3 times improvement in the range of illumination that we can achieve based on calibrated tests that we've done on the ground. So we're waiting to test these operationally in the air, but these should allow us to see ground textures from around 800 to 1,000 feet up, whereas a typical landing light will generally only give you texture down at 300, 400 feet at absolute best. So really excited to see these tested in theatre. So in addition to the enhancements of the focused nose lights, or the main landing lights, we've also, as you can see, got our wingtip lights. This is essentially the arrangement of optics and LEDs that are mounted within that wingtip cluster. These are just functional housings that we're using to do calibrated tests on the ground, and then we'll subsequently use to do flight tests at some point in the future. This second optic here provides about a 2 to 3 factor improvement in the overall illumination, and also provides a profoundly more focused beam of light. You'll also notice that we've also got the working element of the navigation lights mounted in this cluster as well, so that we can demonstrate that the navigation lights are visible where they need to be and not where they shouldn't be. We've done a final version of the the wingtip cluster, which not only provides the latest LEDs and optics as from the last set of ground tests we did, but also provides an improved, larger array of optics and LEDs specifically focused on providing very wide illumination. So again, remember, these are only useful when you're in the final stages of your descent and you need to be aware of what's around you to make sure the rotor disc, the tail, and everything else is clear of obstructions as you start maneuvering into off-airport landing sites or when you're maneuvering around airports with limited lighting available from the ground. So the final element of the peripheral lighting system is to use the signature lighting strip rather than a navigation light as a striking white light to support the wingtip lights in providing improved lateral illumination downwards and upwards to improve your situational awareness in the final stages of approach or takeoff from a confined or off-airport landing site at night. Let's have a look at the DigiCockpit. Our Duxford shows and the Heli Expo trade show gave a large number of pilots and customers their first chance to experience the DigiCockpit in person, and the feedback was universally positive. So the development team here are now on with the business of getting this implemented and testing all of the critical features for making it work properly. One of the first areas of testing that we've done is the core human factors of the display system as it stands at the moment. One of the particular areas of interest has been the daylight readability of the displays under real operating conditions. In order to do that, we rigged up some simple tests using tablet computers that we were able to take out and have a look at how readable these things are in practice under normal operational conditions. And one of the things that was a little bit surprising is that although the contrast of white on black in principle yields really high contrast that's easy to see, in reality, when you've implemented these things on a LCD display, then black isn't really black, and all that happens is you essentially pick up loads of glare and reflection in the darker areas of the screen that diminish your ability to read some of the white writing. So one of the things the guys are working on at the moment is to tune the colour palette slightly to get the intensity of light coming out of the darker area of the screens back up, and to make these things even more readable under daylight conditions. In addition to that, one of the key areas of development that we've been keen to explore for some time now is this concept of the pass-through video layer. Now, one of the design objectives for HX50 was to create this cosseting cabin, these big, simple to use, easy to see displays right in front of the pilot where he can see them best. Of course, the downside of that is that it blocks some of the view that would have been available in traditional layouts of helicopters with a binnacle instrument panel and glazing all the way down to your feet. Our solution to that was to provide a video feed as the background to your instrument console. And one of the things that we've been testing over the course of the last few weeks is whether that really is viable and whether it's an effective way of restoring the lost vision. One of the concerns that we had was that given that your head position can move in the cockpit and you don't have a fixed reference point, then a camera with a fixed reference point and a fixed focal length might be optically unusual or optically disturbing when you're trying to judge distance and range and perceive threats. What we've found through some simple testing is that that's absolutely not the case. The restoration of the block vision that you get by having the pass-through feed camera is fantastic, and in exactly the same way as you can judge your way to a fixed point on the ground by just looking at the point on the windshield that doesn't move up or down. The same thing applies to the camera feed on the back of the digital cockpit. So the pass-through video feed works really, really well. We've still got a number of optimization steps to do to make sure that the focal length and the type of camera and the position of the camera is optimized for the production variants. But in principle, having a video feed there doesn't interfere with the readability of the displays. It adds hugely to your situational awareness and essentially completely diminishes any disadvantages of having a large 15.6-inch screen right in front of you when you're flying a VFR helicopter. So really, really pleased with that. In addition to that, we've also been doing some extensive work on preparing the digital cockpit for night VFR flying. Now, what that means in complete opposite to what you're doing in day VFR situations, whereas in day VFR, the light coming in from the outside can make the screens difficult to read. In night VFR, the large amounts of high intensity screens that we've got in here can create glare on the windows that become a problem for your night vision. So in response to this, we've developed a much more muted palette of colours and a night theme that will be activated every time you turn the navigation lights on the outside. This gives you a much more muted set of colours, massively reduces the glare and reflections that you get within the cabin, and makes night flying much, much easier with the DigiCockpit. All of the panel brightnesses are similarly adjusted, and the colour palette is much more suitable for night flying. So really pleased with how that's come together. In addition to that, we've also been exploring the use of essentially a night vision system as a pass-through layer for the digital cockpit. So one of the challenges with VFR night flying in a single engine helicopter is that in the event of an engine failure, if you're anywhere away from a built-up area, then you really have no ability of seeing what you're flying over until you're 200, 300, 400 feet off the ground, by which time you're just a matter of seconds from impact, and you really don't have any time to find a safe place to land. The beauty of an infrared camera or a night vision system is that essentially gives you the ability to see what you're flying over, even in really, really low light levels. And so that means you're afforded essentially the same number of options you would have during day VFR flight to select a safe field to shoot an approach towards, and then by the time you're in range of your landing lights illuminating the ground, you're already in a position where what's beneath you is viable to land on. It is totally game changing for night VFR flying for private and commercial pilots alike. So really, really excited by the potential of this. The other great feature of this, of course, is one of the other big threats for night flying in VFR conditions is it's really difficult to see clouds at night. And what this IR system also does is it makes the presence of low-lying clouds much easier to see. They appear as big black areas of diminished visibility passing across the screen. So the night vision system not only gives you the ability to land in the event that you've got a warning light or an emergency light illuminated. If you had a power failure and you had to auto-rotate, you could turn yourself into wind and select a field that looked viable a long time before your landing light system is able to illuminate the ground. And then on top of that as well, you also have the added advantage that it makes clouds much more visible at night time. So between these range of technologies, both day and night VFR flying are greatly enhanced through the palette and technologies that we're developing here in the Hill Digital Cockpit. Let's talk about GT50, the heart of HX50. So the primary focus of the engine team at the moment is getting as much of the developed hardware onto the test bench as early as possible to validate and prove that each of the elements of the engine are working as designed and as intended. Over the course of the last few weeks, we've reported that all of the internal elements of our starter generator unit have been manufactured. All of the electrical components, the stator, the rotor, the magnetics, the coils, all of those things have been produced and are now ready to be assembled and tested. We've been producing the external casing components here in-house, and now that we've got the machine shop back online, those final components are now trickling through. So we've got the main casing, the end cap and the front cap. These in production are cast components that then have second stage machining operations on them. For the purposes of the first prototype starter generators, we've rapid prototyped as an analogy to casting and then machined those right here in the new PC1 machine shop. So the last of these components will be going through the facility over the course of the next week or two, just in time for our high-speed test bench to arrive and be commissioned just over there in the development test area. Once we've got the test bench operational, the first starter generator for GT50 can be fired up and tested throughout its entire operating range, along with the power management unit that controls and manages the starter generator and chops up and reprocesses all of that high voltage, high frequency AC electric that it generates back down into usable 28 volts DC. If we then talk about the speed reduction gearbox, the next area that we're pushing through the machine shop at the moment is the speed reduction gearbox that takes power from the power turbine at 35,000 RPM and brings that down into a more usable 5,000 or 6,000 RPM. The challenge with the gears is because at the moment we're still relying on external subcontractors for some of the plating and hardening processes. This is actually a 16-week manufacturing process to get the gears done. Over the last month or so, all of these gears have been released out into production. The blanks have been prepared and these are now busily off being copper plated ahead of coming back to us for tooth cutting and then subsequent hardening. With the gears and the casings and the shafts all released, the guys have then turned their attention to the test rig design for the drivetrain, because as soon as that gets here, this will be built up and we have to prove that that speed reduction gearbox can stand up to the duty and the performance that we need before we can run it with the whole engine as a system. So we're currently developing a system where we can wind that gearbox up and essentially run that throughout its entire operating life to validate the life of the gears, the bearings, qualify the lubrication system and validate the overall performance and strength of the system. While Craig and Rob have been focused on getting the speed reduction gearbox out of design and into production so that we can produce these components as fast as possible, the remainder of the team have been focused on the core of the turbo machinery. The compressor impeller has been ready for some time now, and we're really now just waiting for the climate controls to go back into the machine shop so we can do the finished machining operations on the turbine ready for test. The compressor disc and a lot of the core shaft components have been mature for some time, and again we're really just waiting now to get the machine shop back online to be able to produce that. One of the areas that's developed extremely rapidly over the course of the last month or so has been our in-house casting processes to produce high integrity super alloy cast turbine blades. Casting's a pretty horrible process in principle. The idea of pouring molten metal into a mold which is flowing turbulently and entraining all sorts of horrible stuff with it, controlling that is not a simple thing to do and requires a lot of careful design of the process. What we've been doing over the course of the last couple of weeks in particular is refining the filling system that allows us to very smoothly and cleanly get high quality metal out of the crucible and then down into the filling system through a series of filters, and then to gently and smoothly fill the blade cavities to create good quality defect-free turbine blades. In order to do that, we've had to do extensive design work on the filling system, the integration of our molds with the actual casting machines that we're purchasing to produce these things. We've had to develop specific high temperature seals and gaskets to be able to seal the mold cavities to the casting machine itself, and then we've been doing an extensive amount of work on optimizing the process parameters itself, including tweaking the molding temperatures, tweaking the superheat temperatures, and controlling all of the temperatures and timescales that are necessary to control the casting process to the tightest of details. In addition to the core development of the process, we've also been equipping PC1 with all of the equipment necessary to cast turbine blades in-house. So we've now received delivery of our first casting furnace. This is a mold heating furnace, and what this allows us to do is it allows us to heat the molds that we use to create the turbine blades to really, really high temperatures to ensure that the liquid metal remains liquid long enough to fully fill the casting cavities within the molds. In order to do that, We've also created specific flasks and all of the arrangements to attach our moulds to the casting machines, preheat them in the preheating furnace, and then the apparatus to transfer them into the casting machine for pouring, filling, and cooling and solidification. Clearly this furnace isn't big enough for production. This one, once it's finished its development tasks, will become part of our quality procedures for checking various elements of the casting process. We've simultaneously ordered a much bigger unit that's capable of producing the volume of blades that we need to in early production. The reason we've bought this one now is simply because it's available today, so it allows us to complete the development of the in-house casting processes, and more importantly, go over to Germany in the course of the next couple of weeks and do the factory acceptance tests on the actual melting, pouring, casting and solidification machines that we'll be using to manufacture the Hill high pressure and low pressure turbine blades for GT50. One of the areas that's received extensive testing over the course of the last month or so has been the integration of the fuel nozzles with the swirler system that promotes a swirling turbulent flow at the back of the combustion chamber. This flow is intended to create a stable recirculating flow back here that promotes the ignition of the fire from one fuel injector to the next all the way around the annulus, and make sure that that heat remains at the back of the combustor where fresh fuel is consistently injected. That same turbulence then propagates down the combustion chamber and allows the mixing of the dilution air that comes in through the large holes in the surface of the combustor to create a nice uniform hot gas stream to feed the compressor turbine. This work has involved a combination of extensive sophisticated simulation work and a lot of basic testing back on the bench to verify that what we see in the simulations is what we're getting in the engine. Off the back of this work now, we have a robust swirler design. We've managed to improve the flow around the combustion chamber so that we get as uniform a flow as is humanly possible within the constraints of the packaging, and we've got a nice stable flame giving good flame temperature, good metal temperature, reliable ignition and reliable stable combustion all the way through the range of operations that we're able to cover on the first rig. In addition to the optimization of the swirler arrangement, we've now also completed the development of a duplex nozzle. A duplex nozzle is a nozzle system that takes two simplex nozzles and combines them in a coannular arrangement. Now, why that's important is because in order to get effective atomization at the low fuel flow rates that you need to start the engine, you need a much smaller nozzle orifice than you do for delivering all of the fuel that you need at the high power end of the engine. Now, to make that work uniformly and smoothly across the operating range, we've combined these two things into a duplex nozzle arrangement and packaged that within the swirler that's required to create the stable combustion at the back of the combustor. Pavel's developed the geometry for that, and we're currently going through the first stages of producing the very first production grade combined duplex nozzles for the engine. These are the nozzles that will run in the second set of combustor tests and in the full gas generator tests. You've followed us producing the annular combustor over the course of several months now, and this is one of those components that it's relatively difficult to develop all of the processes that you need to create all of these rolled profiles, pressed profiles, spun profiles to the tight tolerances in the extremely tough materials that are used to survive in these extremely aggressive environments. We finally managed to finish the last of the difficult components that was proving very challenging to form, and we've now produced all of the components necessary to make a full annular combustor. So the next stage for this is to produce a set of these components, set them up in the rig that we've shown you previously, and then we can go about essentially creating all of the welds between the individual leaves to turn this into one solid annular body, ready for drilling, ready for the installation of the fuel nozzles and for testing on the rig. So, next steps for the GT50 program. With the last components for the starter generator going through the machine shop as we speak, and the test rig for the system on its way to us ready for installation right over there in the test area here at PC1, our very next task will be to get the starter generator and its control system, the power management unit, on test and working properly. While that's going on, we'll be completing the build and then the testing of the speed reduction gearbox and the entire GT50 drivetrain, qualifying that for running both with the whole engine and then later for flight tests. While that's been going on, the team is extensively focused on getting the last few components of the combustion system working and the whole gas generator on the bench and running, generating 500 horsepower. And that will then lead kindly on to getting the whole engine working and running as a unit for the first time on the test bench. Activity across the programme has been at fever pitch. We've closed DC 1, 2 and 3 and relocated the entire team here to PC 1. We've taken delivery, installed and commissioned our brand new composites gantry mill and relocated our entire precision machining shop here to its new home at PC 1 and brought our composites pattern, mould and laminating shops with us as well. We've installed our oven to cure composite parts and installed an all-new paint facility to paint all of the first HX50s. And in the meantime, the engineering team have been developing the Generation 2 fuselage ready for production here at PC1, all of the exterior cabin lighting and refining our renowned digital cockpit and GT50. Thank you, and it's time for some questions.
Wow, Jason, what a whirlwind of an update. So many things going on there. So exciting to see PC1 coming together now. The amount of things that have been going on in the last couple of months is absolutely incredible. Really nice to see everything. Thanks for giving us an update. Thanks for taking your time for that. And we're going to dive right into the questions. Make sure you guys are posting your questions on the chat, and we're going to pose those to Jason right now. So why don't you lead us off with the first question?
Super. Yes, from Sean, we have the first one, Jace. Why was the decision made to have the main rotor spin anti-clockwise like the American helicopters and not clockwise like the European ones?
That's a golden oldie of a question. It's really just convention. British helicopters spin the same way as American helicopters, and the reason for that is it came down to where the early helicopter companies got their expertise from. So whether it was from Russia or those countries or from the West. So yeah, British, American and German helicopters spin that way, and French and Russian helicopters spin the other way. So we're just falling in with convention.
Excellent. And Justin and Becca are asking, what was the total square footage of DC 1, 2, and 3, and how does that compare to PC 1?
So, that's a good question. DC 1 was around 7,500 square feet, and DC 2 and 3 were both 5,500, 6,500, and this is 76,000 square feet as it stands at the moment, and it can go up to just over 100 if we do some more mezzanine space.
What would be the type of the landing gear that would be fit in the first flight prototype?
Do I even need to answer that? Wheels.
Okay, easy questions to start with here. That's good. We're going to get to some more technical stuff. Does Hill make the wheels, the wheel hubs and brakes as well?
Yes, we make all of that. We don't do the tyres. The tyres are currently a standard size, but there is a discussion going on at the moment with respect to the HeliMove system as to whether we do a custom tyre to allow the wheel hub to be a bit bigger without it increasing the overall size of the tyre. But that's something we'll report on a little bit later. So we make the wheels, Dunlop make the tyres.
And just a question on that, actually, just to follow
What do you
up.
have?
Sorry, Ruben. Is there ability to make the tires like a run flat tire so that there was no way that it could get punctured and go flat on you?
Yeah, it's definitely possible. There's lots of ways you can do that. We've done nothing about that yet. It'll be something that we pick up in the future. The tyres are always going to be a relatively cheap commodity, so we'll just make sure that we're backwards compatible with the ones that come as standard.
Will our helicopter have ADS in and out built in?
Yes.
Whether it be satellite based or radio or both?
The plan is for it to be both.
Okay.
So both in and out and both on radio and satellite?
Yeah.
Okay. Very nice. When will the HX50 prototype be flown? It's a big question for you, Jason.
Yeah, the timeline as it stands at the moment, we haven't changed. We need to get the build of PC1 done and out of the way, and as soon as we've done that, we can crack on with building the parts and flying the helicopter. So we're going to do a root and branch review of where we stand once we've got PC1 finished. But as it stands at the moment, there's no changes to the plan.
Okay. And just to branch
Given
on
the
that,
challenge of painting.
Sorry, Ruben, I keep cutting you off there, but PC1, when do you expect it to sort of be fully operational and for everything to be running the way that you want it to be running?
So in terms of fully operational, that's not really a fair question because we're going to keep adding facilities to it over the course of the next year or two. But in terms of the main things that we need to get done to be technically fully operational, we've probably got another month or two's worth of work to do. So by towards the end of the summer, we should have everything in here. So the laminating shops, the trimming shops, all the stuff that we need to contain the dust and keep everything clean. The mezzanine will be finished shortly, which will allow us to get the machine shop temperature controlled again and get that back to making precision parts rather than just the commodity machining it's doing at the moment. So yeah, I think a couple more months and the key stuff should be done. Things like some of the test facilities and things, we'll build them as we use them during the test program.
Right, and given the challenges of painting and composites that were spelled by Jason, how does that affect any aftermarket painting job as the HX50 ages and is subject to the elements and it will eventually need a new paint job? Will that affect the cost and selection of paint shops as well?
As with all things, there'll be procedures in the maintenance manual that describe how the helicopter needs to be prepped and then painted to make sure you don't do any damage to the composite structure. Any facility that's practiced and competent at painting composite structures won't have any difficulties. We're not using anything fancy in terms of paint. It's just the interplay between the prep, the mold, the molding, and then the painting processes that we use is what's required to get that first paint job to the standard it needs to be. So subsequently, I don't expect it'll cause you any major problems. It'll be like painting anything else that's composite.
Beautiful. How does the modular airframe build contribute to the requirements for the buyer to build the aircraft under the restricted sports aircraft certification?
It doesn't really change that. It just makes it a much more practical activity. As I said in the update, the challenge with the traditional, with the original version of the tooling was that so much of the work had to be done from inside the tools, and that means you're limited with how many people can work on it at one time, and you're limited with how many areas that you can work on in the order that you have to build the airframe. And as it gets progressively more laminated and built up, you end up with more and more stuff in there that you can't touch or tread on or bump into. The new approach allows us to work on open tools for much longer, so it just makes it easier to get more people around more tools and build the whole thing faster. So all it does is make the process easier for you. It also means that if you damage anything or scrap anything during build, you've only scrapped a portion of it. So you'd have to be very unlucky to scrap one.
Will the fuselage still be a monocoque with the carbon fiber wrapping all these smaller components?
Yes. Yeah, that doesn't change at all. It's the tooling that changes, not the structural concept. It's the tooling. One of the other changes that we introduced about a year ago was looking at bonded B-surface components rather than integral cores. The integral foam cores are quite problematic from a manufacturing point of view. So some of the internal structure, as has always been the case, is bonded in there rather than built in situ. So that's the only difference. But in terms of the recent stuff, it's really just about how we make the tools rather than how the structure works.
Great. Next one is asking, is everything still on track for completing engine firing by summer 2024 and prototypes flying by the end of 2024?
Again, we'll give a full update on that once we've got production center 1 up and running. As it stands at the moment, we've still got about a month or 2 to go to get to the point where we can machine precision components. So some elements of the engine will take another month or so to be able to build. So we're there or thereabouts, but let me get PC1 built and we'll give you a very clear picture once I've got the certainty on that.
Right, with the current technology available in LED lighting, will there be a low, medium, high for the nose and landing lights?
Our intention for this at the moment is to keep the whole system very simple. So the tests we've done on the latest generation of the landing light system give you more light than you could ever wish for, and it doesn't create glare when you get down to the ground. It's all set up really very intelligently. So the intention is it's a very simple system to use. You flick it on and it works. There's your landing light. And what happens is that the wingtip lights, you only really start to notice the effect of those as you get closer to the ground, because they're simply not powerful enough to punch through from a great height. So no, you don't need multiple settings. You just have the one setting and it works a treat. And we have tested this now very extensively, so I'm very confident in what these are going to offer.
Okay. And Neil is asking, I reckon that there should be a pilot directional control capability available. I'm not sure that I fully understand the question.
Yeah. So a steerable landing light. Yeah, we recognise that need and that capability. It's not part of the standard equipment because there's quite a lot go into those lights, but we'll certainly offer one as an option. We've done nothing about it yet. We can look at either interfacing with one of the standard ones that are available, although they're quite big and clunky, or you can give us the time and we'll develop one using our LED technology and make that an option for you a little bit later.
How does that work, Jason? You have the servers on the LED, like small servers, and you direct the light as you turn and go.
Yeah, it's on a
climb or descend, is it?
Exactly. It drops down. It's on a little gimbal, and it's got a pan and tilt system, so you can point it at wherever you want to go. And there's the opportunity to make them quite smart, so you can gyro stabilize them and keep them pointing at a point on the ground if you want to. And there's all sorts of stuff that you can do with them, but that becomes an engineering project in its own right if you're not just going to buy one of the systems off the shelf. So again, as I've said in the last few of these updates, we're very focused on minimum viable at the moment. Get the basic airframe working, then we'll move on to all the options, and then we'll move on to all the nice to have options after that. But right now, I want my engine running and my aircraft flying. And my factory built.
There we go. And from Steve Buchan in Canada. Hi, Steve. When flying through a Class C airspace during the day, where lighting is LED, folks often leave landing lights on. Do you expect to support the use of a small number of modules being illuminated for daytime running?
Yep, we can do that. That's no problem.
I guess with the ability of LEDs, they're not getting hot, so they can technically be on any time, right?
Yeah, these ones behind me have been on for 4 days.
Okay.
So the modules themselves have got something like an 80,000 hour life, so they'll be fine. Yeah, that's not a problem. They don't draw a lot, and they can be used as much as you like.
Very good.
I think you need to buy a new helicopter before you buy a new LED, right? I think
that's the key with these LED modules is there's quite a lot of technology built into them. Firstly, you've got to get the cooling right so that you can keep the chips themselves, the dies themselves, within an operating temperature range that gives them the life that they need. And then within each of these modules, we actually put multiple LEDs under each of the optics. So if one of them fails during service, there isn't really a perceivable change in performance. You don't suddenly have a dead spot in your light. So we're designing them to run really well, and then we're designing them to fail kindly. So yeah, there's lots of stuff that goes into those to make them robust.
Very nice. Guido's asking what's the status of the flight simulator software, and I can just give a little update on that. So there's multiple stages to that. We want to make sure that the flight simulator, when it does come out, is as accurate to the realistic aircraft as possible. And so the flight dynamics go into that. And so once the flight dynamics are completed, then we're able to complete the actual airframe and the digital cockpit and so forth as well. So we're still probably about 9 months away from that at this stage to have that totally completed, to be able to run on a flight simulator. So look at around Q1 of next year to see a fully operational flight simulator.
Next question is there any way to get the internal dimensions of the cabin, including exact door dimensions, close and open? I like to already start trying to figure out how to get a litter in there. What is a litter? My English is limited on that word. Litter?
The litter is for EMS, it's a stretcher.
I would wait a little
okay,
while
okay.
to do that. To be quite honest, there are some subtle changes that you won't notice aesthetically in the Gen 2 fuselage that will change what you've seen here. And one of the options that we're exploring at the moment, I don't know whether it will make it to the final configuration or not. It's literally just on the designers' workstations upstairs at the moment. Is it might be possible in the second generation fuselage to take one of the B pillars out and create a different door system for C that would allow us to have a big door at the side and allow you to get a stretcher in. Again, I can't comment any further on that at the moment. It's something we're evaluating. We don't know if it's possible, but I wouldn't suggest you start designing things for that yet, because we might have something that will make your life a whole heap easier.
Okay. And the next one is from Steve again on the display visibility contract testing and you testing the display outdoors with the pilot wearing sunglasses and polarized glasses.
We haven't done polarized glasses yet. That's a good point. We need to go and have a look at that. But we have done outdoors and sunglasses, and it's fine. These screens are 1,000 candela, and they can go higher if we need them to. So the visibility is really, really good. As with all of these things, it's the nuances of exactly how it behaves in our cockpit and exactly how it behaves with the specific coatings and interior trim combinations and all the other things that create glare and reflection that we're just working through at the moment. But rest assured, they are really, really good. We're talking about polishing something that's already really good. They're really good.
Okay.
Interesting. Next one is about some specific fuels. Could alternative NATO fuels be used with this aircraft? So Avtour F-35, AFTAG F-45, AFCAT F-44, etc.
Again, we've answered the fuel question extensively in the past. For its initial launch, we'll be approving it for standard grades of jet fuel that are available around the world, and a couple of bio-alternative fuels as well, to ensure that we're environmentally responsible right from the day one. We will look at other fuels where there is a legitimate customer need for it, but remember, for us to warranty the engine, and there's much more to come on warranties and things over the course of this year, for us to offer the level of warranty and protection to the customers that we want to, then we have to have tested the engine throughout its full life with all of the things that go through it, different lubricants, different fuels, to pick up the corrosion and the chemical effects that can go on in all the crucial parts in the engine. So it's not as simple as just seeing if an engine will light up and seeing if nothing drops off in 100 hours. We really have to do a lot of bench testing to qualify that with the level of confidence we need if it's us that's going to be picking up the bill on warranty claims for things. So we will look at it where there's a genuine customer need, a general geographic need, we'll do it. But it won't be every fuel that everybody wants.
Okay, very good. Next question is from James. And also, by the way, people, now if you have any technical questions, this is the moment. So make sure you're putting any technical questions that you have for Jason in the chat, and he'd be happy to answer those for you as well. So James is asking, the video feed on the digital cockpit when coming in for landing, is that standard? And for the night flying, night vision, is that included standard or as an additional option as well?
Yeah, the video feed will be standard. I think that's an important part of the standard offering. The night vision stuff will be an option. That will be part of either the advanced digital cockpit or a standalone option. The camera itself for that is relatively expensive. So for those of you that know what night vision goggles cost, then we've bought half a night vision goggle there.
Yeah.
Also from Steve, the night theme being activated when you turn on the nav lights may not make sense. On overcast days where night theme is not desired, nav lights are likely to be enabled. Tying these two together will be problematic.
Yeah, I'm sorry about that. That was actually an error in the video. We've spent 2 solid days shooting various things for that video, and I said that, and we haven't had time to change it.
Yeah.
It's so well done for spotting it. Yeah, it doesn't make sense. Other manufacturers have had the same problem with EFIS screens and things, so we know all about that. It will be triggered in a far more intelligent way than that, so that you can select it independently of the nav lights. My mistake. You got me.
We have to throw something in there for it to get you on.
The crowd won, Jason Hill.
How does the IR system perform during rain?
We haven't tried that specific camera in rain, but with clouds and things, it's amazing. We've also got to extend the testing of it to different, at the moment we're in the height of summer here, so the ground gets heated a lot during the day. We need to test it in colder places, and we need to test it when there's less differential temperatures in the different ground textures as well, to fully assess the usability of it in different parts of the world. We've really just looked at that as a preliminary concept for whether it could add to night flying safety, and it really does. If we need to switch to a different system, there's possibilities for that as well, but there's still some more work to do on that.
What is the SHP, horsepower?
What is the
SHP? Maybe sustain? Yeah.
Sorry, I don't understand the question. Say that again.
I think it's for the engine, the SHP, so the shaft horsepower.
Yes.
Shaft horsepower.
Yes.
The shaft horsepower is 500 horsepower. It's no change. It's what it's always been.
Okay. And the next question: how does the high turbulence system work?
The high turbulence. Oh, in the combustor.
Yeah, I believe so.
Is it related to the combustor? Okay. So in the if you think of a candle burning wax in a flame above it, you can blow it out really easily, right? And that's because the rate at which a flame can propagate upstream is limited to a relatively low number. It's less than 100 meters per second under normal conditions, something like that. Now, it's very easy to get air speeds inside a combustion and a gas turbine engine far higher than that. So it's very easy to blow the flame out. So all combustion systems work by creating an area of recirculation where you can keep those hot gases trapped just in the area where you're injecting fuel, so that you can keep that you've got a source of oxygen, fresh air, fuel and heat all in the same place, so that you can create the fire. So to do that, the way the annular combustor works is we deliver compressor delivery air around the outside of the combustion liner, inside the combustion case, and then the vast majority of the air punctures through the case by 2 different sets of dilution holes. The first dilution holes just act like an air dam, so that it's like the air dams you get air curtains you get when you go into high-rise buildings. It provides that wall of higher compressed air that essentially traps the air that comes in through the swirler behind it for long enough for it to keep the fire going. And then that air gradually works its way through the air dam, and then the next set of dilution holes, as we call them, will mix that air. There's another set of holes along the casing that bleed air along the surface of the metal to keep the metal protected from the flame temperature of the combustion process as well. So that whole process is a very delicate balance of hole sizes and discharge coefficients, so we get just the right amount of air going into just the right part of the combustion chamber. It's a lot like trying to balance your central heating system at home, right? You loosen one too much or you tighten one too much and all the hot water goes to the wrong end of it. A combustion system's a lot like that. So we inject fuel and then swirling air from the back. It gets trapped by the first set of dilution holes to recirculate, and then gradually works itself down the chamber, and more air is added to bring the flame temperature down, and you end up with a nice uniformly distributed temperature of hot combustion gases going into the first stage nozzle guide vane. Simple, really.
On the optional infrared camera, will you support selectable false color filters? Being able to rotate through a few false color filters is helpful when landing on mist-covered ground surface, a dry ground surface.
So we are looking at a standard color filter, because at the moment the very white image that I showed you from the test footage completely blows out our dark theme. It doesn't look right with that at all. So we're playing with color filters, and we're using all of the colors you'd expect to for a night vision system. So we're looking at the muted greens that your eye is most sensitive to, and we're looking at a couple of related colors that fit well with our color palette for the DigiCockpit. So I don't know whether we'll do selectable ones for the main display, but it'll certainly be filtered for best effect all round. Yeah, that's where we are with that.
Okay, excellent. And Kevin is asking, do we only have one power turbine wheel? Maybe
Yes.
give a little education.
Yeah, single stage gas generator turbine, single stage power turbine. We started in the very early days with 2 stages for the gas generator, but we've only ever had 1 stage for the power turbine. They're really nice, efficient turbine wheels. It's just, there's how many years? There's probably 40 years worth of difference in technology for some of the engines that we're used to flying around between where we are with this one, just bringing it up to date, and those, so we can get a lot more out of the wheels than we used to be able to.
What types of NDT will help having NDT in-house?
Everything. That's something that we've been developing now for over 12 months. We'll have a full suite of NDT capabilities: ultrasonics, X-rays, dye penetrant, magnetic inspection, full destructive test capability. All of that has been ongoing for about a year. We don't have a lot of the equipment here yet, but we'll be starting the procurement of that over the next 6 to 9 months, I expect. At the moment, we're using a lot of outsourced inspections for that, just because a lot of that kit's quite expensive.
And Jason, just to give an overview of some people for the benefit of the technicality of getting a bit more knowledge on this area, can you give a little bit of details of what are these systems going to test? What's going to be the process? Because this is a common question people have. It's a new helicopter, and what is your quality process? What is your quality testing? What are the systems they have in place? So this type of details, I think, is really important to educate people on the testing phase and what are the systems that are going to be used. Can you give a bit of overview of that?
Okay, so let's start with the basic concept. The way aircraft design and certification works is that when we design things, we design things to a known set of operating conditions and loads. Those are the things that form the limitations in your pilot operating handbook. So don't load it any more than this, don't fly it any faster than that, and keep it within this CG limit. If you do that, then the helicopter operates within an envelope that we've analysed for and we know it's strong enough for. And then the designers design parts using material properties that represent the materials that we're going to buy. So a material will have a certain strength, a certain stiffness. Now, when that material comes into the factory, we need to make sure that that material lives up to the assumptions that the designers made when they designed it, and it's exactly the same as what we tested it when we tested it and certified it. So we have to prove that the design intent is fulfilled and that we've actually made a good job of producing it. So if you take the example of a turbine blade, for example, then when we create that blade, we need to make sure it's the right shape, because the shape affects strength. So we measure it geometrically. We have to make sure that it fits next to its neighboring parts that it connects to. So we have to very carefully check the fits and the tolerances. We then need to make sure that all the material that's supposed to be there is there. So we X-ray it to make sure that there's no holes inside it, pores or defects or cracks or porosity. We need to know that that piece of material is as perfect as what the designers assumed it would be. And then on top of that, out of any given batch of material that we produce, we need to make sure that when all of those things have done, it's actually got the mechanical properties that we've assumed in the design process. So for most of the for all of the critical materials that come in, each batch that's produced will be tested to destruction. We'll test for all sorts of failure modes, and they vary depending on what material it is and what manufacturing processes that it's been through. But we'll test material from each of the batches that come in to guarantee that. If you then look at something like your fuselage, for example, when we produce the fuselage, there are areas around the doors where we can cut off coupons. So little bits of the fuselage that were made at the exact same time as your fuselage that we turn into little test coupons, and we pull and we bend and we prove that material in that fuselage does exactly what the designers assumed it did, and did exactly what the material did on the machine that we tested for the approvals process. So you're verifying that you've got what the designers intended you to have, you've got what we tested when we certified it, you've got a perfect example of a HX50. So that's how you qualify the materials. But then in big structures like this, you're also looking for the kinds of defects that can occur during production. So one of the test pieces that we used to use on composite panels was you'd leave little bits of debris inside the laminate so that you could calibrate the ultrasonic inspections and the x-rays and things. So we're looking for bits of debris that might have got in there. We're looking for contaminants that might have got in there. We're looking for bond failures, for anything that can possibly go wrong with that structure that can affect its ability to do its job. We inspect for, we look for, and we test for as part of the standard manufacturing process. Now there are a whole myriad of processes that we can use. X-rays is a big one. Just as you get X-rays for your legs and your bones and your skeleton, we can do that on solid parts as well. So all of your high integrity mechanical parts are X-rayed to make sure there's no holes in them, there's no cracks in them, there's no inclusions in them. We can look for surface defects, like things that, if you think of a machining operation where we're pounding material with really sharp, hard blades, it's possible to tear and to rip the surface of the material to create little defects on the surface that in time will become cracks and fatigue failures. So we look for surface cracking and surface defects. When we're grinding the fir tree roots on the bottom of your turbine blades, or when we're grinding your gear teeth, it's possible to create so much friction that you overheat the case hardened material that gives the gear its life. So we look for scorching and we look for burning on the surface of the teeth to make sure that we haven't done that. So all of the combined knowledge of all of these processes over many years are built into the inspection process and the way we make these helicopters, so that when it leaves here, we know we've built you a perfect replica of exactly what we tested. And we know that what we tested can do everything that the pilot operating handbook says it can do. So you fly within those limits and you'll be okay. And that's how the whole process works, really.
Fantastic explanation.
Really good. Thank you for that, Jason.
Really, really nice. The next question is from Daniel. It says, where will you test in Germany? Will the IABG Munich be involved in certification process and fuselage testing?
It's not that kind of testing. What we're testing in Germany is that the casting equipment that we're buying to produce turbine blades can do all of the processing that we want it to do. We're basically making sure we can make our blades our way with our processes on these machines. So it doesn't involve any third parties, it's purely internal.
Excellent. Next one is a simple one, but a very, very useful one. Also great to answer this generally to everybody. It's regarding visits. When can I come over and have a look around, do a tour? Do you have a helipad? What is the length of the tour? And again, when are we resuming tours? Can you give a little bit of a good overview of the tour possibilities right now and what is planned on that, Jason?
Okay, so Our policy has always been to be really open. All of the people that have supported us over the years, all of the people that are interested and want to be involved, and we maybe haven't hit their criteria yet, whatever, you are welcome. We want you to come to PC1. We want you to come and meet the team. We want you to come and see the aircraft and get to touch it and feel it for yourself. Our doors are open. What we're doing is, obviously at the moment we are building a massive helicopter factory. We've got workmen and we've got all sorts of heavy machinery being moved around. The place, despite what that video looked like, the place is a bit of a shambles at the moment. So what we're doing is, as soon as that's done, all of the standard organised tours will happen, and then every Wednesday, I think we're scheduling them for, we'll be having organised tours where you'll meet Amy, our customer services specialist. Will show you around the facility. You can see everything that we've built here. You can meet the guys that are making the helicopters. You get to meet some of the design staff. You get to sit in the helicopters and enjoy it for yourself. We're starting those from September. And the reason for that is, by then this will be less of a building site, and the place will be presentable from a customer perspective. Until that point, we're asking people not to come, simply because it's a nightmare to show people around at the moment. Until about 20 minutes before we went on air here, you couldn't even hear yourself think, because they were hammering and banging the mezzanine floor together. So it's not a great place to visit at the moment, but it will be from September. So from September, the doors are open. We'll also be offering limited ad hoc tours for people that are in the UK on business. But until then, we just ask you to be a little bit patient with us, because we've got such a lot on our plate to get this place put together, that as excited as we are to see you and welcome you, we've got to be realistic about what you're going to get out of it at the moment while we're building.
Okay, excellent. Very good. I like that. Carlos is asking, would you be so kind as to comment on how much is the production capacity of the HX50 per year? So what are you planning for production capacity?
So production starts at 475 a year in year one, and then goes up to 675 in year two, and then 1,000 in year three. Now, as we've said all along, those are the capacities that reflect our current order book. If we continue to sell at the rate, we'll ramp up sooner than that. We have a modular approach to manufacturing now, so adding more space is much more flexible and much easier than it had been up until this point. So those are the numbers at the moment. I don't anticipate changing them anytime soon, but if we continue to get a flood of orders as we go through the milestones, we'll of course revisit it. The simple fact is, if you want a helicopter sooner rather than later, you need to order sooner rather than later, because as these things fly, the orders will fly out the door.
Mm-hmm. Some time ago, you were really excited about the amount of energy produced by the starter generator. More than expected and needed is what I recall. How many excess amps will be available for the owner to use in accessories, LiDAR, HD, camera gimbals, lasers, etc.?
That's a good question, and I actually don't have the numbers off the top of my head. I think during normal operation we're only using about 20 to 30% of the power. You've got your usual big draws with the air conditioning and the air conditioning and the landing lights. Our landing lights are much lower powered than everybody else's, so yeah, we've got sufficient for all of the options that we're anticipating. If you send us an email in, I'll find you the exact number out, but I'll have to look that up. I'm a mechanical and aerodynamicist, not an electrical guy, I'm afraid.
Okay, excellent. And Michael's asking another question that I can answer. It says, what are the sales numbers to date for both the HX and the HC50? So right now we're sitting at 932 HX50s sold and 372 HC50s. So that's where we're at the current moment.
And Philip is asking, how does the duplex fuel nozzle switch between the startup and running stages? Mechanical switch or dual fuel lines?
It's dual fuel lines in our system. So I had to pause then because we've looked at both. It's dual fuel lines.
Okay. Taylor's asking, how long will it take to do all the testing and airworthiness to allow flight testing? When do you expect to take that for that to take place?
Again, that's the same response as what we said earlier. Let me get PC1 fully operational, and then we'll have a really clear idea of where we stand with that. At the moment, I'm not in a position to produce any more composites until I get my composites department back together. So let me get that built, and then I'll answer that properly.
I think the question also stemmed more around what is the time frame?
Yes.
From the time that you first start your test flying to the time that all the test flying is completed and the certification is done, ready to start production, what would that approximate time frame be?
It's different. It's different for X and for C, but we would expect the test flying process and the certification process and the ramp up to run the production facility scale up to run in parallel over a 12-month period. So all of the key flight testing we expect to be able to get done in a 3 to 6 month period for the X model.
With the Hill Helicopters app, do you have a special passcode to access the app? If so, how do we get that done? Okay, this is a simple one. It's about, I believe it's the existing app for clients, and if we have access to that, yep. If you're a client, you will have full access to the app, and the app is only for clients. It's a platform where the company shares the updates in a much more frequent way. Weekly by Jason, and also there's a community app. You get to interact with other owners worldwide. You get to make ask questions to Jason, suggestions. Something really special about the Hill program. So once you become a client, you have access to the app, which is the platform of both-way communication. So that will be answered already. Go ahead with the next one then, Misha.
Yeah, absolutely. Neil's asking, so if I place an order today, how many years before I get delivery of the aircraft? I need to decide if I'm likely to be alive and flying by that point. So just to give a little bit of an overview on where we are on that as the time frame sits today. So with the orders that we have for both the EX and the C, we're anticipating somebody, if they're ordering an X today, they could expect to see that aircraft around the end of 2027 is what we're estimating at this point. And if you're ordering a C, and that's obviously because the over 900 orders that we have, and then if you're ordering an HC50, it would be early 2028 approximately to be receiving that aircraft. So it gives a bit of an idea of time frame if you're ordering today when you could see that aircraft.
All right, and I see. I remember you stated in an early update you will be eliminating the angle gearbox to strengthen out the main drive shaft by real the engine in the fuselage. Is this still the case?
Yep, that's all been done. That engine that we've got over there is a legacy one. So the bevel box has gone. The engine now sits slightly inclined up, pointing straight into the first stage bevel reduction in the main rotor gearbox. And that's yielded a really significant weight saving and a huge simplification of that top deck for us. So yeah, that's really nice, works really well, very happy with that.
Very good. And Alexandra is asking a very important question that I think we all want to know is, does the helicopter have a key like a car?
It does. It has a key, so if the central lock-in doesn't work, you can still get in. So the key barrel, you probably saw when I got in, you just tap the door handles and they'll open a little bit, and there's a little key to remove the deadlock in there if the central lock-in doesn't work. The rest of the time, it's just on the fob.
Okay. I think the question is probably more centered around
emergency float.
A fob like you would have in a car.
Yeah, you'd have a fob. We have a fob. That's another project for Henry.
On the emergency floats, how do they attach to the helicopter? How are they mounted? Where are they hidden? Where is just the floats? How are you going to be applying them?
Yeah, ask me that again next month because we're working on it right now. So we've got a couple of schemes at the moment for the pocket areas that go into the structure, and they're not quite there yet. So ask me that again, and I'll include some images in the next update.
JC, be very happy to know that question didn't come from Carl. So surprisingly, it was a that was asking about floats.
He's probably already texted me.
Excellent. Next question is from Carlos. What is the package dimensions in square feet of the HX50 with the blades retracted in order to send it to other countries? Is there a special container for shipping by sea? So maybe just explain for people about removing the blades versus folding them if it's gonna be packaged to be shipping.
Yeah, like a lot of helicopter manufacturers, we've got a packaging scheme for HX50. So it comes off its undercarriage, the gearbox remains attached, the blades come off, the tail comes off, and then it will go into a 40-foot shipping container. So there's some crating and there's some shipping equipment that goes with it, and then it breaks down and goes into a container. So it's not a complicated process. We do it much the same as everybody else.
How far are you with all the airworthiness certificates? Is it going to be to EASA, FAA standards at the same time, or first one and then the other and then the other one? How does that work?
So we've actually got a big meeting with the UK CAA in the middle of this month coming. So you can expect a big update from me on where we stand with all of that on the next update. We will be doing the UK approvals first, just because all of the definitions of the airworthiness materials and the basic approach we're taking needs to be ratified before we then duplicate that around the various other authorities. I'm talking about the X at the moment, and then once the X approval materials are established, then we'll be doing parallel approvals with all of the major authorities. So it starts with the UK, then we go through the X process, that goes internationally, and then we go through a parallel process for C.
And that leads perfectly into the next question that's asking, how far do you think behind the HX50 will the production of the HC50 be?
I think we're still about the same as we always have. There'll be about a 2-year delta, something like that. That does assume that we get the attention we need from all of the approval authorities. But certainly in the UK, I expect that's not going to be a problem.
Will the first HX50 be entitled to an update equipment as it becomes available on newer models, obviously free of charge? Okay. So new equipment being available
in terms of
what is critical safety or not. Yeah.
So in terms of patches and software updates and things like that, yes, we'll do that. If it's new functions that weren't in the specification, then no. If they're retrofittable, you'll be able to purchase them, but you wouldn't immediately be entitled to those. In terms of if there are problems with the early aircraft, then that's covered by the warranty anyway. If there's a defect with something that we've produced or a safety issue, that would be picked up during as part of the warranty.
Excellent. Sprague is asking, is there any update on the development of the rotor blades? Are they built in-house as well?
They are built in-house, and you know that lovely big gantry mill that I've just shown you, that's what we're going to be making the tools on. So the guys are being trained on that this week. As soon as they're trained on that, one of the first jobs is to start making composite rotor blades. So yeah, there'll be much more coming on that shortly. All the blades are made in-house in their entirety.
When do you think the gantry mill will be starting producing the molds, Jason? When do you think that's going to be operational?
It should be operational by the end of this week. That doesn't require any temperature controls or anything. So yeah, that's almost ready to go. The guys are literally having their training on it this week, and then we're ready to go.
So it's one of the first equipment's going to be producing again at the PC1. Actually, one of the first at PC1.
Yeah, all of the CNC machines have been operational now for a few weeks, but as I said, only for low tolerance parts. The gantry mill will be the second large piece of equipment to be operational, and then composite laminating and all of the clean rooms and things have to be fitted later, because we're using that space to store all the stuff that we're building at the bottom end of the factory. So once we've cleared the decks, we can put the rooms up. So yeah, the gantry mill will be operational by the end of this week.
What is the estimated maximum flight time with the auxiliary fuel bladders? Will those be available? And where inside the airframe would they be placed?
So the HX50 comes with a 5-hour fuel tank as standard. And so that gives you 700 nautical miles of range anyway. That's at maximum continuous power. If you squeeze the power off and fly at best range speed, you'll be north of 800. If you want to then trade passengers for additional ferry tanks, we haven't designed any additional ferry tanks for the aircraft yet, but it's possible, and we'll make sure the fuel system can take it. But beyond then, you're into trading off a fuel burn of 30 to 35 gallons an hour with your passenger weight. So I could see a range in excess of 1,000 nautical miles if you wanted to fit ferry tanks. How good's your bladder?
That's the real question.
More important
Bachman
tank
is
in our
asking,
context. Yes.
Yeah.
yeah, why are dark colors not affecting the carbon and resins in a negative way? They always want a white color to protect the carbon from heat.
Yeah, it's still an issue. You still have to be careful with it. But on the top of our tail boom, for example, where you've got the upward-facing surfaces that are most vulnerable, that's not a structural part. That's a cover, because we have the continuous engine drive deck, the transmission deck, across the whole back of the helicopter. And then up the top, again, they're non-structural composites. So they're only there to cowl in the mechanical systems. All of the structural composites are much more protected, or in much less vulnerable orientations.
Okay.
All right, now reading the next question, it is presented on the question with EMS variant. Would it be possible to remove the entire cockpit side of the cockpit? So instrument panels, screens, and all that on the co-pilot, not just the controls?
The simple answer to that, as it stands today, no. The DigiCockpit screen will remain. We haven't designed an alternative digital cockpit. There's nothing to say we couldn't, but we haven't done it yet. So let me get the basic one working first. Once we've done that, if we needed to do a variant with a different cockpit, most of that stuff just bolts on top of the structure anyway. It's not a big ask, but one thing at a time. If there's a market, we'll look at it.
Okay. Greg is asking, is PC-1 capable of production of customer aircrafts or just the prototypes? If so, what number of aircrafts per year can PC-1 produce when fully operational?
PC-1 is likely to form a part of the overall manufacturing strategy. So we will need a bigger assembly hall, but a lot of it, we will end up using PC-1 as either the composites production center or the machine shop. And then we'll take on a bigger assembly hall just before we need it. So PC-1 is not a limitation on our production volumes. It's appropriate for our needs at the moment, and to do a part of the production that we need for the rates that we've declared.
I was wondering, what is the distance from the center of the nose tire to the center of the main landing gear tires, as I'm building my helipad? Well, that information is on our website. So all the dimensions of the helicopter are available to everybody. You can check that on the helicopter website, and it will have all the precise dimensions for your planning. We have several clients with helipads and also hangars, so that information is fully available. Just check it out on the website and it will be there.
Yeah, you would just say it's a good idea to make a big helipad. Don't make it so it just fits.
Exactly. Next question is regarding funding for the next stage, so for mass production. So being that you have the deposits that you've received at this point for development, what is the plan to source the required funds to build the production facility necessary for mass production? I think mass production probably meaning when you ramp up to 1,000 aircrafts per year type of thing, or extending beyond that with future aircraft.
Yeah, so the way our payment terms have always been structured is to keep us as cash positive as is possible. So the payments declared at 12 months and 3 months before are all to support that scale up. So essentially that is the primary plan, to use positive cash flow to scale up. By using rented facilities and using asset finance and things like that, we can essentially fund a lot of these things directly from cash flow. If there's a gap, we'll use debt finance like anybody else would, and other standard commercial instruments. So yeah, that strategy has never really changed.
Will the POH be a booklet or also available on the display system?
It will definitely be available on the display system. It will live as a live document in the customer app, so the pilot portal of the customer app as well. And I can't remember off the top of my head if we actually have to have a paper copy in the cockpit these days in the latest amendment, but we probably do. So we'll probably have to have a book in there, but the real live document will be a live cloud-based thing that you have access to through the Hill app.
Excellent. And Milos is asking, what difference do you expect between the max takeoff weight and the dry operating weight?
That's a very good question. Say that again.
I mean, the useful load at the moment is 1,760 pounds. I think
Okay,
that's
so-
sort of what they're asking. They're
Yeah,
asking
so-
the difference between the max takeoff weight and the dry operating mass. So dry operating mass wouldn't include any like fluids in your transmissions and things like that, but I'm not sure why that would be a relevant question.
Yeah, in terms of your payload, the payload is 800 kilos as it always has been. So there is a reasonable amount of additional fluid in there, hydraulics, oils, and what have you. I think that amounts to around 20 kilos of various fluids, maybe a bit more than that actually. I've never actually added them all up independently. But that's all included in what we call the empty weight, so the ready-to-go empty weight. So 800 kilos is your payload.
The next
I think
one
that's
is
the answer to the question.
Right, the next one is very interesting, but I think the answer is going to be even more interesting. So the Honda realized early on that it needed help with the engine development. Then it partnered with GE to make the engines for the Honda Jet. What, if anything, do you have set up should you come to place if you get stalled in the engine development?
Okay, that's a good question. So fundamentally, there is a world of difference between a state-of-art business jet engine that operates in a really competitive market where performance and fuel efficiency are everything to the validity of the performance of the aircraft, to where we are, where we produce helicopter engines where the competition has a relatively poor fuel efficiency anyway. The market accepts a relatively low performance level for these engines, and those targets are a lot easier to hit than what state of. So let me put this into perspective for you. Our engine is about 25% thermally efficient. The state of art for a commercial airliner is up at 50%. And some of the other aircraft engines out there that we're familiar with are down at 17 and 19%. So the bar for us in the helicopter world is a lot lower than it is in business jets and commercial airliners. So we don't need the same level of technology. We don't need the same level of manufacturing capability. We don't need the same level of sophistication in the engine that those guys did. They've had to develop a much more sophisticated engine than we have. This is a very simple engine based on very simple technologies that the rest of the gas turbine engine grew out of back in the 50s and 60s. So it's not the same challenge. So first of all, I don't expect that problem. I think we're going to be fine. And then my solution to that, if I couldn't recruit the people directly that we needed to solve the problem we've got, and these people do float around the industry, they're not beholden to the individual engine companies, then people's doors are always open, aren't they, if you've sold enough helicopters? So we could always go and ask if we needed to. I really don't think that'll happen.
Okay, excellent. Next question. We're just getting down to the last final few minutes, you guys. So it's been a really incredible session. Lots of really good questions today. And thank you, Jason, again, for taking all your time. We're just going to go through a few more questions here, and then we're going to wrap it up for today. Another really good session. Next one is coming from Scott. As a high-hour fixed-wing pilot and a relatively low-hour helicopter pilot, is it reasonable for me to have this helicopter, the HX50, as a personal helicopter?
That's a really good question, and Misha's probably as well qualified as I am to answer this one. But what we set out to do here is to design a helicopter for people like me, right? Low time, inexperienced pilots that don't fly a lot, where the machine itself is set up to be as benign and as easy to operate as it possibly can be. So to do that, we've brought together all of the ingredients that make flying easier. So if we start at the top, we've got a 3-bladed high inertia rotor system. That means that in the event of an engine failure, you've got as much time to react, and then as much time as much leeway to make a mess of the flare at the bottom and still be okay as we can possibly give you. The fact that it's got 3 blades means that the handling qualities of the helicopter are very benign. It's much easier to fly and to operate, and much more stable in gusty conditions, turbulent conditions, and more aggressive maneuvering than other sorts of rotor systems and lighter rotor systems. So starting with that makes the whole position of the whole act of flying a helicopter easier. The next thing that's really important is power, right? Everything is easy in a helicopter when you've got power. You can make bad approaches, make bad landings, but you can always pull yourself out of it. So we set off from the start to make sure that the aircraft has got a big enough payload so that in almost all operating conditions, you're never going to be near gross weight. And even if you are near gross weight, the fact that we've done the engine means that we can design the engine that the aircraft really needs. That means you've got enough power even when you're at gross weight, even when you're at high density altitude. So you've got a very robust, modern, efficient rotor system with high inertia and benign handling qualities, powered by an engine that's got bags of power. Then we've given you modern crash-worthy seats to protect you in the event that you do have a mishap. A composite fuselage that gives you great rollover protection in the event you roll it over, so the cabin volume is protected. And then on top of that, it becomes about reducing the workload for you as a pilot. We've made a 2-axis autopilot standard, so this aircraft essentially will fly itself. Once you're in the air, you've got essentially the aircraft version of cruise control, and this thing becomes stable as opposed to a conventional unstabilized helicopter. You're constantly balancing that ping pong ball on your fingertip and using all of your mental capacity just to keep it the right way up. That's not the case with HX50. It's stable because it has an autopilot. And then on top of that, we've put the digital cockpit in there, which means that the workload associated with navigating and communicating and operating the aircraft has never been lower in any aircraft out there. So we've made an aircraft that is tailored as closely to the needs of private owner operators that don't get to fly every day as it could possibly be. All of the well-known nasties we've taken out of it, and we've given you the best margin that you could possibly have, and in my view, the best margin of any of the light aircraft out there from the perspective of a private owner operator.
Fantastic.
Nice.
Next one is a funny one, but important, very important. How will you ensure the manufacturing process gets followed up on the scale up? Example, Boeing had issues with forgetting to install 4 bolts for the door plug that fell out of the flight.
Yeah, again, another good question. Essentially, we will receive an enormous amount of scrutiny from our own Civil Aviation Authority and the other agencies around the world because we are a new manufacturer. I think we will receive a level of scrutiny far beyond anybody else that's in the marketplace at the moment because we're new and because the helicopter's different. And then it's for us essentially to develop a process that tracks not only that everything's done, but everything's done exactly as it should be. We've described a little bit about the NDT processes that we use to prove that we've made things the way we want to, but the full production facility will also include essentially a digital build log for every aircraft. So every step of the manufacturing process will have a digital signature and will have evidence to show that everything that should have been done is done to put the helicopter together correctly, and that build log becomes part of the documentation that's required to sign it off as an experimental in the case of the X's, or as the build log that goes into the qualification for the build of the certified aircraft. And that's part of our core process for making sure that every aircraft gets built exactly right.
Excellent. Last question for me today is from Carlos, and then Ruben's got one more question as well. And I just want to invite anybody that is interested to learn more about the HX50 and wants to find out more about the aircraft itself, all the specifications of it, and the possibilities to pre-order the aircraft. You can actually book a session with Ruben and I. So we do daily Zoom presentations. It takes about an hour total because we have a Q&A session at the end of it. And so if you want to learn more about that, you can go to the Hill Helicopters website and book one of those, and we'd be happy to meet you and answer any questions that you have there as well. So last question for me today, thank you again, Jason, for your time, is from Carlos. It says, with 900 HX50 orders so far, what factory expansion projection do you have in mind to reduce the waiting time to receive an HX50?
Well, as we've said, that's chicken and egg. At the moment, if you look at the historical path that new product introduction helicopter orders take, you get a peak for a few years, and then it flattens off to a long-term demand. So for me to build a substantially bigger helicopter, I need to see the continuity of a substantially bigger factory. I need to see the continuity of those orders into the future. So I can assure you that we will react to large numbers of orders. We already have expansion plans to go up to 350,000 square foot, which will get us, in theory, to 1,000 aircraft a year. And we can go bigger than that if we need to. It's a case of renting more space, taking on more people, and buying more machines. So we will do that if it's necessary, but we need to see the orders to do that.
Excellent. We have arrived at the last question, and what a way to finish it, because this one is a curiosity that I'm also curious to find more about, and it's super interesting. Which area, Jason, has been unexpectedly tougher to deal with during the entire development?
That's a really easy one. People. all of the engineering is fine, right? That's just time, and physics doesn't change. It just does what it's supposed to do. When you get the answer right, it just works. But the people side of it, the scarcity of technical resources everywhere in the world is a major challenge, not just to us, but to all technical businesses. We're a little engineering company in the middle of the UK, right? And I think I've got every nationality on planet Earth working for me now, as we've pulled people from all over the world, you know. And so that's been unexpectedly difficult, unexpectedly time consuming, and is a frustration. And when I talk about technical people, I'm not talking about the wonderful production staff that we've got. I'm talking more about the design specialists, the analysts, the approval specialists, all those sorts of guys. There's so few of them in the world that really know what they're doing, that it's that's a challenge to scale up, and it's a challenge to doing both this program and our expansion plans go into multiple programs in parallel, and that will be the limitation, how quickly you can bring those people to you. In all honesty, in terms of the technical stuff, I don't think there's anything here at the moment that's been more difficult than I thought it would be. The time it takes to do everything is always frustrating, particularly if you're having to use external subcontractors while you develop the capability before you can productionize it and bring it in-house. But no, nothing technically has really stood out as a major challenge yet. I expect we've got a few to come, but no, the biggest challenge in all of this is people.
Fantastic. Great way to end. Thank you very much, everyone, for attending today. We had a great attendance, and we're going to have a next one coming up. We're going to be announcing that date very soon. As Misha said, we invite you to attend one of our presentations that we do daily if you have not attended yet. And this is the Hill Way. I want to emphasize that, in fairness, it is the first time that it's been done in aviation history where the company is updating constantly not only the clients, but also the entire market, the entire public. This one has been another example of that. We have reached probably almost 30 of these updates, and we're going to continue to do that, not only until production, but also after production. We have a whole new plan, a fantastic, ambitious plan to keep the world updated. What are the Hills plan, especially the vision of Jason Hill, which is going to go beyond what you see today. Thank you very much, everyone, and have an excellent day, morning, afternoon, evening, whatever you are.
Thanks, everybody. Thanks for your attention and thanks for your questions.